Okay, welcome. So now we are on Unit 2, and this is the unit on differentiation rules, or basically how to take derivatives easier than we did last unit. So, as we discussed last unit, a derivative is the line of the slopes of a line, and we write it as if the original line is f of x, then the derivative would be f prime or f apostrophe x. You can then take further derivatives by doing f double prime of x, and then f triple prime, and so on and so forth. After 3, you would start using the number, so it would be f with a little 4 on top, and then the x. So, another way of writing derivatives is writing them as typically dy dx. dy dx is basically saying, if the original function is y, dy dx is saying the derivative of y, can you see this? The derivative of y in respect to x, meaning that there are x's in the equation that you're taking the derivative of, and the equation is y. So, for example, if the equation was y equals x plus 2, the equation is y, and there's x's in it, so the derivative of this would be dy dx. If this was y equals r plus 2, then this would be dy dr, and other various examples. So, in this first section, I'm just going to talk about a few of the rules of quickly finding the derivatives of lines. The first one is the simplest one, and this one is called the constant rule. Oh, also I should mention another way of writing if you just want to find the derivative of something, you could do d, the derivative over what you're taking the respect to, and then brackets, and then inside here, you would put what you want to take the derivative of. So, constant rule is basically if there's just a number in here. So let's say it was just 5. Whenever there is just a number or a constant inside the derivative, then the derivative just equals 0. Because think of it. If you had a line and it was just y equals 5, it would just look like this. The slope here is 0, the slope here is 0, the slope here is 0, the slope here is 0. So the derivative would just be y equals 0. Okay, so basically, the constant rule is that whenever there is just a constant here, known as c, the derivative is 0. This is the constant rule. Alright, the next one we'll talk about is the power rule. Now the power rule, I'm sorry, just one second. The power rule is when a function is just a variable, or it's a variable to a power. So for this example, let's do, well, first off, we should just say, what is the derivative of x? Note that in this notation, this would be the same thing as saying, if f of x equals x, then what would be the derivative? It's just a shorthand notation. So, if you think of the graph of this, it looks like this. That's y equals x, and the slope at all these points is 1. So, the derivative of this is 1. Now, without graphing this, how could you figure that out? Using something called the power rule. The power rule, I'll write down the formal definition here, is a x to the n equals a times n times x to the n minus 1. Now this looks very messy, and I'll explain. Can I cover it? You can kind of see it if I cover my hand there, but then you can't see this. Basically what this is saying is if you want to take the derivative of some variable to a power, then you would pull down what the exponent is as a coefficient in the front, and put this coefficient, or put this exponent down 1. It'll make sense if I show you an example. So if we do right now the derivative of x squared, we'll pull down the 2. So if you were doing the derivative of x squared, pull down the 2, and then it would be x to the 2 minus 1, which would just be 1, and x to the 1 is just x. So therefore, the derivative of x squared is just 2x. Okay? So the derivative of 4x to the 5th, well, the coefficient in the front doesn't affect anything, so you would just pull down that 5 and multiply by the 4, so it would be 20x, and then 5 minus 1, which is just 4. That's the power rule. Last rule I'm going to talk about in this video very quickly is not even really a rule, but it's just a situation, and that is if you ever have something, and we'll talk about more complex versions of this later, that is just e to the x. E to the x is a very, very awesome derivative to take because the derivative of e to the x in respect to x is just e to the x. It never changes. E to the x, its slope is e to the x. It just repeats over and over again, which is actually very interesting. And you can do a proof to find all these out, but I'm just going to go ahead and skip that and just show you these. So, reviewing, if you're taking the derivative that's just a number, then the derivative is going to be 0. For the power rule, you pull down the power, multiply it times the coefficient, and then put the power down by 1. And then for the derivative of e to the x is always e to the x.